All right, ladies and gentlemen, today we're going to look at the video notes for Unit 2, Lesson 3. Here's the warm-up. So in the first one, I had 2 points plotted, A and B, but there were no coordinates, so I had to put in the coordinates and then use the slope formula to solve for the slope, 3 over 2. In number 2, I had to combine like terms. So I circled the x terms, boxed the y terms, and got 6x squared minus 3x. And then I also wrote it in factored form. This will become more important over time, where I pulled out the greatest common factor from these two linear, one of the quadratic and linear term, and that was 3x, open parentheses, 2x minus 1. If you redistributed the 3x back inside, you would end up with 6x squared minus 3x, same thing. Okay, and number 3, we were asked to find the slope. I just labeled the points and plugged it into the formula, got 1/2. For number 4, we were asked to solve for x. This was that situation where I had to find the least common multiple and then multiply each term by whatever denominator I needed to multiply the factor to get it to turn into 12. So I got everything equal to 12, and then I multiplied out the 12s, and then I solved for x, and you end up with 0. You end up getting x equals 0. Okay. Now on to number 5. We were asked to simplify. So this first required me to distribute the squared term inside the parentheses and apply the product rule, adding the exponents. Then I got x to the 5th plus 4x squared minus x to the 5th minus 4x squared. When I combine like terms, everything simplified out to 0. Number 6, I had to factor 128 down to primes. So everything turned out to be 7 times. And I listed it several ways. So that's not just one way to write this. The product of the primes can be written in a lot of different ways. So here it is, it just says 2 to the 1st 7 times. Here's 2 to the 2nd 3 times 2 to the 1st. 2 to the 3rd 2 times 2 to the 1st, or 2 to the 4th times 2 to the 3rd. You could just go on and on. You could rearrange this. It could be 2 to the 5th times 2 to the 2nd. That would be the only other way to write it. 2 to the 6th, I could do 2 to the 6th times 2 to the 1st. You could just go on. So that's different ways of writing those factors. And that's the warm-up. So here's the actual Unit 2, Lesson 3, how to write the equation of a line. I say there are many ways to write the equation of a straight line. Slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. Importantly, this form cannot be used for vertical lines, okay, because the slope is undefined. Benefits are you can read the slope instantly, you can read the y-intercept instantly, and it's really easy to graph a line using this form. So here we take an example, y equals 2x plus 3. Instantly read that the slope is 2 and the y-intercept is 3. So the rise is 2, the run is 1. We plot the y-intercept first, 3. Then we go up 2 over 1 and draw a line. Okay. We also solved for x to find the x-intercept, and I set y equal to 0. So 0 equals 2x plus 3. And then I solved for x, and I got negative 1.5, or negative 3 over 2 equals x. That's the x-intercept, where it hits the x-axis. That brings us to all about intercepts. The y-intercept is where the line crosses the y-axis. Y-int, b, and y sub 0 are all the same way of referring to that. X is always 0 at the y-intercept. So the coordinates right here at the y-intercept are 0, 3. And the x-intercept is where the line crosses the x-axis. The x-int is also called the root, or the 0, or x sub 0. Y is always 0 at the x-int. So at the x-intercept, it's negative 1.5, 0. Obviously, we're on the 0 line for y when we're on the x-axis. Okay, and then I think I'd just show another example here. Y equals 3/5 x minus 2. And we do exactly the same thing we just did above. All right, so then there's some practice here. And we're doing the same thing that we did for those 2 example problems in our notes here in the practice. Okay. This will be scanned and linked in the description and in the pinned comment. So if you want to look at these notes, please be my guest.